logarithms. So, logarithm, like rhythm and blues. Log, R, logarithm, logarithm. How do you break it up into 3 syllables? Log, a, rhythm. That's how you say it. Does everybody want to practice going one at a time? They said no, they don't want. Carly will. Logarithm! She would yell it. So, okay, so a logarithm, this first blank is the word logarithm. A logarithm, if you need to know how to spell it, it's right above. Let's not get crazy, it's right here. A logarithm answers the question, how many of one number do I need to multiply to get another number? So, for example, how many 4s do I need to multiply together to get 16? 2. Well, we need to multiply 2 4s together to get 16. So the logarithm is 2. It literally tells you how many times should you take this number and multiply it together. That's why I had you write down this quick cheat sheet here, because logarithms are based off of, like, how many times would I need to multiply 2 together to get 32? Well, the logarithm would be 5. So that's basically what it's showing you right here. You can also be asked this question in an equation form. So the equation form is, how many times do I multiply 4 together to get 16? You guys told me that was 2. So x is 2. Because 4 squared, or 4 to the 2, is 16. Okay, how many times do I have to multiply 2 together to get 16? 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this one is 4. The logarithm is 4. How many times do I multiply 3 together to get 27? 3. 3 times 3 times 3 is 27. So then we get this really weird one. How many times do we multiply 2 together to get 10? Well, that would be 32. 2 to the 5th is 32. So, turns out that we don't have a nice whole number to put here to make 2 into 10 by multiplying it together. But we can use a logarithm to find out. And it turns out that you would raise it to the 3.3219. It's a big old long, ugly, irrational number. So logarithms make it so that we can actually figure out what this x is. We could actually figure out how many times do I multiply 2 by itself to get 10. So today we're doing a little bit of this. We're doing a little bit of finding the logarithm, but mostly we're talking about how you write a logarithm in log form and exponent form. So this left-hand side is called logarithmic form. Logarithmic form. And notice he's got a log. Logarithmic form means you're going to have the word log in it. How you read this is log base b of y is x. You'll feel better about that after we do examples. It might seem a little bit crazy right now, but I promise it's much more manageable once we actually have numbers. So you would read that log base b of y. Then the next one, hopefully we're a little bit familiar with. This guy is exponential form. He's exponential because we have b written as the exponent. So this one exponential because it has an exponent. This one logarithmic because it has a log. So the first part of this lesson is rearranging from one to the other. So we can change these back and forth. We can change these back and forth. So I could give you a log equation and ask you to write it like this, or I could give you an exponent equation and ask you to change it back to this. So these y's are the same y. And this b is the same b. And this x is the same x. So let's look at it. This says take all of these logs and rewrite it as this. So I got a really easy way for you to do it. You can do it this way every single time. So log base 2 of 16 is 4. Log base 2 of 16 is 4. So how do I rearrange it? Bring the 2 down, because remember this is log base 2. Bring that 2 down and make him a regular sized number. He's not a little number anymore. So bring him straight down. And that's the new base of your exponent. So log base 2, that 2 turns into the base of the exponent. Then you do an x, meaning you take this 4, you cross it over to the exponent position. Then you take this 16, you cross it over, and that's what your exponent is equal to. So here's what log base 2 of 16 is really telling you. You would raise 2 to the power of 4 to get 16. So remember, the question is, how many times do I need to multiply 2 together to get 16? That's 4. So 2 to the 4th is equal to this number here, 16. Are you hanging in a little bit? It's just rearranging the way you're writing it, but they both mean the same thing. So this question is asking, how many times do I need to multiply 4 together to get 1? Well, that seems impossible, but if we follow this procedure, we would bring this 4 down, and that becomes your base in your exponent. Then you crisscross. This 0 becomes the power, and this 1 becomes the answer. 4 to the power of 0 is 1. So how many times do I multiply 4 by itself to get 1? 0 times. Okay, let's check this next one. This one is asking, how many times do I need to multiply 12 together to get 12? The answer to that is, bring 12 down as your base. What does your exponent become? 1, thank you. And that equals 12. So this is saying you multiply 12 by itself, you have pretty much 1/12, that equals 12. Okay, let's do a couple of these before we take our last one. So you can write them on this page that gives you lines if you want to. You can write them on the page that has your, I'm going to write them here. I'll write these problems on 75. I just want you to try a couple of normal ones before we do anything crazy. So, log base 3 of 27 is 3. So this is saying how many times do I multiply 3 together to get 27? You guys rewrite it. In fact, let me give you 3 to rewrite, and then I'll walk through and see if you were able to do it. Okay, those are the 3. I want you to write those as exponents instead. Bring the base down and then crisscross. Okay, about 20 more seconds. Ten. Okay, so this is equal to 3 cubed equals 27. 2 to the 5th equals 32. And those are backward. Did you guys notice that? This would mean 2 to the 7th is 49. Is that true, though? No. 2 to the 7th is something bigger than that. 128. So I needed to switch these. I should have had a 7 here and a 2 here. So what you have when you write your exponent should be true. Like it should be true that 3 to the 3rd is really equal to 27. Now when you go to write these in Canvas in your quiz, you're going to do 3 caret 3 equals 27 with no spaces. So you have ones that you will type in like this, but instead of having the exponent, you have to do the caret thing. Do you feel okay about the rearranging? Okay, so now let's solve some that are similar by just thinking about it. And well, actually we have one more here, sorry. I left this last one off. So this guy, our last one, I wanted to save him because this time your exponent will be a fraction. So what this turns into is if you raise 16 to the power of 1/2, you get 4. So if you raise 16 to the power of 1/2, you get 4. And let's just make sure that I'm telling the truth. So I'll plug that into my calculator. 16 to the 1/2 is 4. So sometimes you'll have fractions. In Canvas you won't because it's a little bit more complicated to write a power with the fraction. So we'll just do ones like this in Canvas. So these ones actually wants us to solve. So here they tell us what it equals. But in the next section, we have to figure out what it equals. So A is asking you How many times do I multiply 8 together to get 64? So in math form, it's asking you this. 8 to the question mark equals 64. What is that question mark? 2. And that's where this guy may come in a little bit handy. Because I could have come here and looked, oh, okay, 8 to the power of 2 is 64. So this next one is asking 2 to what power will equal 8? What would I raise 2 to equal 8? So you could come to this cheat sheet that I made you. What does that one equal? 2 to what power equals 8? 3. Okay, this one would mean 2 raised to what power equals 32? That one is 5. Cheyenne was able to get that one so fast because she wrote these down on our other page that we're about to go to. Because these are the most common ones that you see. If you didn't have those, you could just start multiplying them together. 2 times 2 times 2, and then keep multiplying until you hit 32. Okay, then our last one is, what power do we raise 5 to get 1? 0. Remember, 0's that special exponent that turns the base into 1. Do you guys want to practice a couple of these before we move on? Like 1 or 2? Hugo says no. You're Gucci? Okay. So 2 more elements to this lesson. You're halfway through. So element 1 is, how can we rearrange into an exponent? Then evaluate without a calculator. Element 3 is now to take it from an exponent to a log. We're going to take it from an exponent to a log. So this is how you do these ones. It's very similar. So we're going to write log, and then this 5 becomes the base. So you write that down on the tail of the G, because this is now log base 5. Log base 5, and then you crisscross them back, of 25 is equal to 2. So it works the same. You bring down the base number, and then you crisscross the other 2 numbers. Let's do a different one here. Let's do 10 to the 3rd is 1,000. Actually, I think it's 10,000. Let me just verify. It's 1,000. Okay, so this would become log. What number do I write as the base on the tail? 10. So you bring this number straight down. Then crisscross. Log base 10 of 1,000 equals what? 3. And then on this last one, this little box to the side is just a reminder that when you have a negative exponent, it takes that number and puts it in the bottom. So 6 to the third is 216, but because it's negative, it pushes it to the denominator. That's what you're seeing here. It's the reverse of that. So this one would be log base, what number do I write down by the tail? 6 of 1 over 216 equals -3. So you bring the base down and then you crisscross these two numbers.